Hi everyone, I am Azan Akhtar and this is my literature review survey on multi-intense learning for weekly supervised whole slide pathology image analysis. The survey explains what MIL is, why it is matter for unstructured data mining, and how recent methods like CLAM, DSMIL, TransMIL, and cross-scale MIL are applied in digital pathology. Now let's talk about why MIL matters. MIL is important because real-world data is often unstructured and only weakly labeled. Medical slides, document, molecules, and satellite image are large objects made up of smaller parts. But getting detailed labels for every part is expensive or unrealistic. MIS saw this by learning from back level labels only without needing every instance annotated. Now we're going to talk about what is MIL concept and workflow. This figure shows exact paths feature, learn which patches matter using attention weights and combine them into a slide level prediction. Under the standard MIL assumptions, a positive bag has at least one positive instance and a negative bag has only negative instance. A natural fit for pathology where only one tumor region make a slide cancerous. This image pattern apply to drug discovery and document classification too. In each case, the bag level is enough for the model to learn useful pattern without needing every instance labeled. Now we're going to talk about what is categories of MIL. I compared 5 MIL categories across 4 dimensions: core, assumption, modeling, strategy, complexity, and interpretability. Instance space, backspace, and embedded space method are the traditional approaches. They vary in how they represent bag and combine instance information, but generally offer low to moderate interpretability. The two most common important recent one for pathology are attention-based MIL and transformer-based MIL. Attention MIL learn important way for each stance, high interpretability and practical for large bags. Though attention scores are not clinical proof, transformer MIL goes further by modeling relationship between patches and capturing capsular spatial context, but at higher computational cost. Both handle weak slide level level well, and which is why they are specifically useful in pathology. Now we gonna do in-depth review of pathology MIL. Whole slide pathology is one of the clearest MIL application. Slides are large, patch level annotation is expensive, but slide level diagnosis label are commonly available. Campanella, etc. AL showed a clinical grade model can be trained using only diagnostic labels with no pixel annotation needed. CLAM use attention and clustering to identify key regions and produce heat maps evaluated on TCG across multiple cancer types. DSMIL handles large unbalanced bag using a dual stream and contrastive learning approach, validated on Chameleon 16 and TCGA lung attention method on TCGA RCC and TCGA NSCLC through at higher computational cost. Finally, cross-scale MIL aggregate multiple magnification levels, which mirrors how pathology actually examines slides. Across all method, key challenges remain: domain shift, limited clinical and interpretability, computational cost, and the need for external validation. Now I'm going to talk about my finding and conclusion. The main finding is that MIL is a practical solution for weakly labeled unstructured data in pathology. It reduces annotation cost and support disease classification from side level labels. However, attention map are not the same as clinical reasoning, and model can struggle across different hospitals, scanners, and training protocols. Future work need to focus on better explainability, cross-hospital generalization, and rigorous clinical validation before these models can be safely deployed. To conclude, MIL is useful because it learns from weak label without needing every instance annotated. Ultimately, it is a proven practical framework for unstructured data mining, especially powerful where expert annotation is scarce. And I want to say thank you to all for listening my presentation, and if you have any question, any doubt, you can comment below. Thank you.